catalysts are very important substances. We'll see that in chemistry, as well as in biology, catalysts are substances that increase the rate of reaction. They will increase the rate of reaction. And they will do this by changing the mechanism by which a reaction takes place. So often, they change the mechanism. They will use themselves to create a lower energy pathway. What we might consider a reaction, coordinate diagram, is a regular reaction. We have our activation energy, we have our delta H and all that fun stuff. However, with a catalyst, we might have a new pathway. And we see that we end up actually lowering the activation energy of our reaction by using this catalyst. It not only gives us a new mechanism, but it will have us change our activation energy as well in order to make K a little bit higher. And so often these catalysts can work in a number of ways. So primarily, at least in biology and in many chemistry applications, catalysts can kind of bring molecules together in the proper orientation. This is how enzymes work. So enzymes in our bodies catalyze reactions by bringing molecules together in exactly the right way that they need to. And so we remember, again, the randomly just bumping into each other, there's very little chance that they'll actually hit with the correct angles. But catalysts can help guide things together. And so that's one way they can speed up processes. Or, alternatively, let me see if I can spell alternatively. Alternatively, there we go. Catalysts can simply kind of make a molecule more reactive. They can react quickly. They can react to make a molecule more reactive. And this might be something like putting in an iron catalyst with hydrogen peroxide. Interesting, fun, I don't know if you'll have iron 3 hanging around, but many iron-based things will help catalyze the decomposition of hydrogen peroxide. Hydrogen peroxide decomposition is the following reaction. Pretty standard. But interestingly, this thing is pretty slow by itself. But if you have a catalyst in there, you still get the same reaction to happen, but much more quickly. And interestingly enough, the catalysts are going to be consumed and then produced again. So catalysts are consumed and then produced again in a reaction. So we don't really see them in rate laws. So they don't show up in a rate law. So it's simply the presence of a catalyst. We're not going to see them showing up in rate laws. And so when we're taking a look at this, I mean, in the case of iron, we're making some complex ions happen, but we don't need to go into that kind of chemistry quite yet. We'll see that towards the end of the semester. But they don't show up in a rate law. And so if we consider what might be happening, let's take it in the case of an enzyme. We'll say that, we've got H2O2 plus enzyme turns into, here, we'll take an overall reaction. Again, we've got the same thing, H2O plus O2. Will form a complex. And that complex can do all sorts of things. It can bring a new molecule in, that'll be produced again later. It can bring another catalyst in, or it can just yank off that oxygen, or do whatever it may be. It's technically two H2O2s, by the way. We make two water molecules out of this. And so with this, what can happen is you make this enzyme complex. That's your intermediate, as it were. And then your intermediate does some reaction. Maybe it interacts with another H2O2 and it breaks them apart. Or whatever it may be, whatever the pathway may be. Essentially, it's kind of acting as something that's going to help become an intermediate. So notice we use our enzyme, they joined together, formed a complex. That complex found another molecule and did its chemistry, and then spit out the enzyme again. And now we have the enzyme that can go and find another H2O2 and catalyze the reaction all over again. So the enzyme in this case is a catalyst. The peroxide enzyme complex is an intermediate. And so we'll have enzyme or catalysts often form intermediates that will then get kind of released later on. And so again, this is very common in biology. And again, they're not going to show up in the rate law because they're going to be, they don't really show up in the overall reaction either. So we have some examples of catalysts. Here's something you can do to show for yourself. Do it at home. Take some in a glass. Put a little bit of, try a narrow glass so you don't use too much, or like a little bottle or something, or a little vial. Put some peroxide solution. You do 3%. You can get it at Walgreens, CVS, whatever, drugstore, grocery stores, any of them would have it. You probably have it at home. If you do that and compare it with 3% H2O2 with any of the following things, try it out for yourself. Add yeast if you bake at all, if you have baking yeast. Or you can add a potato, a chunk of potato. Or an apple slice. Very interesting. Hydrogen peroxide is a pretty dangerous compound for living things, that is, because it's a pretty good oxidizing agent, as we'll see later on. And most biological organisms have an enzyme called catalase. And this very rapidly breaks down hydrogen peroxide into water and oxygen. And so you'll just compare it. Take a look at the peroxide by itself, then throw in any of these things, and you'll see very rapidly bubbles will form as the oxygen gas is produced. Because potatoes, apples, yeast, these are all living things, or at least at one point were, they still have cells. The cells produce this enzyme catalase, which is ubiquitous. It's everywhere because it's so important to break this product down because it's toxic, so that you want to get rid of it. So all of these things will form bubbles very rapidly. And so you can see a catalyzed reaction happens much more quickly. And you'll also notice your apple slice doesn't go anywhere. It stays the same, at the end of the reaction. Although if you're putting yeast in, it'll just be cloudy, I guess. But you'll try it out. It's fun. 3% hydrogen peroxide is not dangerous. Please don't drink it or anything, but it's used to treat cuts and stuff, right? It's an antiseptic. So try it out. Put it in a little glass, add a potato chunk or some yeast, apple slice, carrot slice, whatever it may be, random vegetable bit. You should see bubbles forming immediately and rapidly. And if you heat it up as well, you can really go crazy with it. So, fun, there you go. There's your fun for the day. So there's your at-home experiment. So Long story short, catalysts speed up reactions by offering an alternate pathway. That pathway is lower in activation energy, and either we're forming a situation where we can put molecules together in the correct orientation much more easily, or we're simply providing that alternative mechanism for this to happen. And so that's all we need to know about catalysts. So we're done with kinetics, as fun and confusing of a chapter that was. Our next chapter will be on equilibrium and how forward and reverse reactions are always in balance with each other.